Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my product development series. This is a new season, and in this season, we're going to be talking about. Basically, I went to San Francisco, the shop.build, and I'm kind of worried about the new shop in San Jose ever being built. From being at that shop in San Francisco. What I'm going to be doing is I'm going to be kind of designing my own machine to kind of as a backup plan to if it never shows up. So basically, what I have come up with is for here at my place, at my parents' place, I have a small spot in my garage, an area about 2 foot by 2 foot, and by the time I release this, you would have seen some of the stuff about the what's it called, the mill that I designed. And this guy is going to be a similar footprint, and we're going to talk more about it and kind of look at some of the design and assembling it. Most of it's probably going to be pre-bought stuff, so I don't know how informative this series is going to be, but I guess you're building something practical. So who knows, I might not even decide to even post this when I'm done, but let's go ahead and spend till 1 o'clock tonight. Which is 27 minutes from now, and see what we could do. So the idea is that I wanted to do at least two things, but a third thing would be really great. So number one is it needs to cut. I would really like it to be able to cut wood. I need it to cut wood and laser etch wood. So that's the number one thing I needed to do. Number two is I needed to be able to cut metal. Metal, I think, is actually number one important. The number one important thing that I need to do is be able to cut metal. Then it needs to be able to cut wood and laser etch wood. And number three, what would be really, really nice is if it's able to route wood or plastics, but mainly wood. So the one thing that came to mind is I caught this video a little while ago. So this is a Waterjet. I don't know if you guys are familiar with Waterjets, but basically they use high pressure water and garnet abrasive, and what it does is it goes through this cutting nozzle, combines the abrasive and the water. The water, of course, is mainly the vehicle that transfers the garnet in through the beam, and it could cut through materials, hard materials. As you see here, it's cutting through aluminum, which is water and sand pretty much, and the sand goes into a bucket and the water goes into the bucket, and it will cut through hardwoods, it'll cut through other soft materials, cut through plastics, cut through foams, all different types of stuff. Now this one here, what he's building it off of is he's using just 200 or like a $300 Waterjet. I mean, sorry, not Waterjet. He's using like a $140 electric pressure washer, which produces pressure at 3,800 psi, which is pretty low. Most for a Waterjet, most Waterjets have pressures in the range of 50 to 60,000. Production grade CNC Waterjets usually have pressure between the 50,000 and 60,000 psi range, and will cut through up to 6 inches of material at a time. Obviously, the thicker the material, the slower that you cut. So this guy obviously is using way lower, like almost it's like 100 times lower or more. It's like almost 150 times, 100 times lower than a commercial grade CNC Waterjet. but yet he could cut a 16th inch aluminum. And what he finds out later is that from this distance right here, he actually doesn't have any water in this pan. It actually starts cutting its way through the bottom of the pan. So it could even cut through steel extremely slowly at a very, very far distance. So this is one of my main ideas, but mainly what I'm worried about it cutting the bamboo for the EcoBase 3D print. I think it'll cut through steel, well, not this one, but I'm going to explain what I came up with. So the main thing that I'm worried about is I do want it to cut through the EcoBase 3D printer, and I'm worried about it splashing back and getting this wood all types of wet. So I think that if it just does this and just goes right through, I don't think it's going to be too bad as far as how wet it gets. So I think that if it's just like this and I clean off this surface, this is just some sort of perf board thing. So if I just clean off this surface and I lower the water level out and it just kind of shoots down like this, and I just have maybe the water at the bottom, and I'm going as fast as I can where it's just cutting it and it's lowering the speed of the water as it comes out down very, very far, I think that I would be able to go through without getting any water on the bottom side and just get this wet on the inside. And then if just one part of it's wet and it's very little water, I don't think much of it's going to transfer through the porous material, because on the edges of bamboo is where it has all of the because it's a grass, so it kind of has all of the veins almost of the wood that will transfer stuff through it. So I just want to limit the water exposure to the sides. But I just was at Tech Shop San Francisco today, and I laser cut apart, and another thing I would really like to avoid is the smoke and also the charring of the edges. So basically I'm going to substitute the charring of the edges with wet edges, but the water will dry. The smoke, you have to do a lot of work and even use some hydrogen peroxide to clean off the charring off the side in order to get it to look nice and clean. So but then again, the laser is very quick, but I think the Waterjet would be even quicker. It took 3 passes of about 15 seconds a piece, so I'm going to say about 45 seconds to a minute to cut a 1 inch by 1 inch square. So if you calculate that on my calculator here, so the perimeter is 1 inch, 1 inch, 1 inch, 1 inch, so 1 inch by 1 inch, so that's 1 times 4, that's 4 inches, divided by 0.45, which is 3/4 of a minute, so that's actually 0.75. So that's 5.33 inches per minute, equivalent. Of course, this is multiple passes, but I'm saying that equivalent to 1 pass, which generally in a water jet you just do 1 pass, because if you don't do 1 pass, all this water reflects out and shoots everywhere and turns everything to a mess. So 5.33 inches per minute. Compared to, I'm sure that with, well, I'll show you in a second something that we're going to compare to. But this guy, so another thing I want to do is I want it to be able to cut wood without spraying water all over the place. So to be able to run on water only mode and water and abrasive mode as well, to be able to do both. Obviously, I want it to be CNC controlled, not pushing my hand, pushing it through with my hands. And I want it to be 20 to 30,000 psi. I'm going to explain to you how that is possible. So there are 2 types of pumps generally used on commercial grade water jets. There are direct drive pumps, such as this pressure washer is a direct drive pump. You have a continuously spinning electric motor or a gas motor. In this case, in most cases in industry, it's an electric motor, and it's spinning at a certain speed. And then you want to a second. Let me do a search here really quick. Fine. Okay, there's so you have a continuously spinning motor, and then you have an impeller, or basically generally what it is it's 2 gears that mesh together, and the fluid will actually go around the outside, and it will compress the fluid. The gears will move the fluid to the outside and increase the pressure. And now that's constantly happening. Now, that obviously with the electric motor, you have a lot of inefficiencies with electric motor, a lot of heat buildup, but you're using water, cold tap water, so generally the cooling is not a problem. So that's what they call a direct drive pump. There is another one instead of the rotors. Another design of a direct drive pump is basically just like a car engine, which is almost like an internal combustion engine where you have multiple cylinders, and each cylinder is a stage of the compression. So you'll have a first cylinder, the water will go in, just straight tap water, and maybe it'll leave at maybe 1400 psi. And then the next one will increase it again. So that first one was like from atmosphere, let's just say, even though when it comes out of the tap it's not atmosphere. So let's just say it's 14 psi atmosphere. So it'll go in, let's just say it was sitting water. It'd go in there, it gets amplified by 100 times. So now it's 1400, and then it'll go into the next cylinder. Now amplify another 100 times. Now it's, or generally it's not the same amount every time. First time's a very big jump, next time's a smaller jump, next time's a smaller jump, next time's a smaller jump. So each time you're building up more and more pressure, takes more and more force, and it's trying to rip that cylinder apart more and more, to where you're finally up to 50,000, 60,000 psi, 40,000, 30,000, 20,000, whatever you want. Or in this case with a pressure washer, it's not a cylinder system, I believe it's a rotor system. And that will get up to 4,000 psi, maybe 5,000 psi. Some of them you get up to like 6 or 7. And now, as you can see, with just 4,000 psi, he cut through 1/16 aluminum and also some pretty thick piece of wood. I think this is even just water only mode at this point. This might be water and garnet. And the garnet, again, is just basic sand. There's two different types. There's crushed rock, and then there's sand, pretty much. So there's two different options, and each option, it has its own strengths and weaknesses. Now, it'll rip right through quarter-inch aluminum, quarter-inch steel that I'm looking at pretty decent speeds. I'm thinking maybe 7 to 10 inches per minute, which is not super quick compared to a high wattage fiber laser or anything like that, or obviously a plasma cutter. Plasma cutter will do 50 inches a minute, and so my shredder is 888 inches of travel divided by 50. So you could do a shredder in 17 minutes on a plasma, but if you have 888 inches divided by 7, let's say 10. You could do it in 88 minutes, so that's an hour and 20 minutes. If you're flying through, and obviously that's the poorest finish, because the faster you go, the poorer the finish. So basically what I'm going to be using is, what this guy's got is he bought all the parts for it, and it's from this website called AccuStream, which is a brand by Hypotherm. And so anyways, it's a brand by Hypotherm, and it basically has all the parts that you need. It has these A2 cutting heads, just like this here, A2 cutting head, which is the same cutting head that he's using. You can see the collet right there. It's the same as this knurled collet here. And you just attach a high pressure line here with a high pressure hose, and then you buy a this is for AccuStream, again Hypotherm brand, and then you buy an orifice, which is either a ruby or a diamond, and the orifice is like $15, and then you can select different sizes, and different sizes correspond to different gallon per minute rates at certain pressures, which luckily online there's a whole bunch of different specs for that. And so that's $15. The cutting head's about $300, and then you buy an $80 nozzle, and generally you buy three 3 to 3 3/4 times the size of orifice. So if you have a 5 thou orifice, you're gonna get almost 4 times more. So it's about 20 thou. So you'd buy like a 20 thou hole, 3 inches long, 0.3 inch outer diameter. So they have anywhere between $85 and $125 for those nozzles. So total about $400 before shipping. Then, in order to make higher pressure in the pressure washer, because I know I want to get as fast of feed rates as possible, and also more flexibility if I decide that I want to do some job shop work with it, be able to cut some other stuff, I want to be able to have higher PSI. And that's where I found this guy, which this guy is one of the cheapest, and I've bought various products off of Alibaba direct from China before, and this is one of the cheapest pumps. Now this brings me to the second type of pump. The first type was direct drive. This is called an intensifier pump, which basically you use hydraulic advantage, which is you push a bigger pump a smaller distance, and on the other side you have hydraulic fluid between, and it will push a smaller head of smaller piston a very, very far distance and produce a lot of pressure. So what this does is this actually doesn't use a motor. This actually uses compressed air out of a compressor. Now at my house I already have a compressor. So instead of buying a separate pump body for a high pressure pump and then buying the motor for it, I just buy the pump part, and I already have the motor for it because I have a compressor. And you see it here, it uses there's a rating on here somewhere. Anyways, you see here, here's all the specs for it. So here we could have the maximum, which is the pressure ratio, is the water coming in and its final PSI. We have pressure ratio of 170 to 1 is 20,000 PSI. And a maximum flow rate of 0.37 liters per minute, which is like about 0.01 gallons per minute. So once you have that information, you have to look through a chart from a company called Waterjet. Pull this up for you. Which Waterjet has a really cool university here. It talks about, just separation cut, all different qualities, pump specifications, and here's the direct drive pump. This would be like the first stage, second stage, third stage, right? And then here's the electric motor that's attached. And so here is where you would use to find the orifice, the orifice diameter that you want to get. So here is your pressure in 1,000 psi increments. So you have 20,000, 25,000, 30,000, 35,000, 40,000. So if I'm using this guy, I'm going to put down 20,000 psi. So 20,000 psi, and I have a flow rate of about it's about 0.09 gallons per minute. So you can see here at 20,000, I'm between a 5,000 and a 6,000. Obviously I do not have enough for the 6,000, but I have a little bit more than the 5,000. So I'd buy a 5,000 nozzle, and then I multiply 0.05 times 3.75, and that's equal to about 0.18 for the mixing tube, which mixes the garnet in with the water after the water goes through the orifice. After the water goes through the 5 thou orifice, the change in pressure sucks in the garnet, and then the garnet is then mixed with the water and then shot out. And then shot out through the mixing tube. And the mixing tube is what I showed you there of the 20 thou. And that is the 3.75 times 0.01875. And I'll show you where I got that information from. This is a company that I saw at Maker Faire. And it's called Protomax by Omax, which is a very, very big industrial producer of Waterjet products. And so I went looking for these specifications to build one at my house because I knew that this was $20,000 machine, and lo and behold, I really I'm really fortunate that these guys put literally all their specs for this machine on here. There's another company out there called Wazer that did a Kickstarter for $1.3 million that is running also a Waterjet, but they don't release the specs for it, while these guys do. So it's a 12 by 12. It'll cut 1-inch material max, plus or minus 5 thou, plus or minus 3 thou, traverse speed up to 100 inches per minute. Now it uses a direct drive pump, so again multi-stage pump, and it takes 5 horsepower to get up to 30,000 psi. And a high pressure water flow rate of 0.22 gallons per minute, and then right here it tells you the orifice size. So they're running an 8 thou orifice. So if we go in here, an 8 thou orifice at 30,000 psi is 0.23 gallons per minute. If we look here, they're saying it's 0.22 gallons per minute. So that's really freaking close. So I'm thinking that that chart's pretty good. And then so 8 thou, and then their mixing tube, they say that they have a 2.25 inch long by 30 thou internal diameter. So if you take 0.030 divided by 0.008, that is 3.75. So that's where I got that from. And then here, what I really like is they have the flow rate of abrasive, because abrasive is actually the most expensive part of this machine to run. Is abrasive, when you buy it at low quantities, not by the pallet, it could be about the same price as $1 per pound. But there's also ways that you could do manually, where you could shift through all of the garnet that's been shot through the nozzle after a cut on the bottom of the tank, and then have maybe like this is using an 80 mesh, which means that the garnet will go through a mesh that has 80 that there's 80 holes per 1 inch, so instead of an 80 mesh, you would try to refilter it through a 120 mesh. And now if it sits on top of a 120 mesh, it's probably good for reuse because it still hasn't disintegrated into a smaller size. So you could run a 120. So like, for example, if you try to siphon this stuff through a 120 mesh, whatever goes through is garbage, and whatever stays could probably be used again. So that would cut down your garnet. I've looked at a few researches, done a little bit of research on it, and it said that it could be anywhere between 30 to 50% reuse or more. Some people have said up to 90% reuse. So that's the Waterjet. Really interested in trying it out. And as you see here, even the pump is not all that much. It's like this particular one I think is $650 plus $120 to get it from China. The 170 is about $650 plus $120. And then what I would get on top of that, let me see if I can find it. Then I have this guy. So this is what I would use to direct it. Actually, not this one. Something like this, just something to drop in with a controller already ready to go. And this has the second thing that I want to do. I want to be able to etch the wood, because that's a big part of the EcoBase 3D printer, is to be able to etch the front side of the box itself, of the frame. So probably not this big, not a 2.5 watt, maybe something like this where it's maybe a 1.5 watt or something like that. So that's the idea. Is this? I would use this guy to control the machine, and I would have it hold a laser diode, which are pretty efficient compared to like CO2 lasers, and you don't need a whole bunch of mirrors and stuff. So it could hold a CO2. It would hold a diode laser that would do all the engraving on one side, and then on the other side be able to hold the nozzle for the Waterjet, and then have a manual nozzle height adjustment, so you can move the nozzle up and down. Then on another option that I want to have is to be able to mount a spindle. Now this guy is pretty weak. I think the corners are made out of acrylic. So that I would obviously if I'm building a Waterjet, I can easily change that really quickly. I just copy it. But what was I getting at? So with the Waterjet, easily cut out, aluminum pieces and then put them in place of the acrylic pieces. And then on the interchangeable with the nozzle, I could put a CNC router head on it that would be able to, something like a 300 watt or whatever laser router head. And then that would be able to route some of the parts that I need in the EcoBase 3D printer. And so now everything, and then for a final cut, for a final dimension size of the finished machine to be 2 feet by 2 feet, I could do 2D cutting for almost any material, right? I could do laser etching of almost any material. Obviously, I think the diode will reflect when you try to etch on metals. But you could use the Waterjet in water mode to etch metals as well. Obviously way more messy, water shoots everywhere. So you would take the router head out and then, the laser head out and then do that. So that's another option, but it would be nice to have maybe a little diode laser or something in there that you'd be able to route metal, that you'd be able to laser etch metals, be able to laser etch woods, be able to do all that stuff, and then obviously we need fume evacuator at that point, and then have a router head where you could route maybe soft aluminum, soft aluminums, plastics, woods, stuff like that. Would be perfect. So an all-in-one machine that takes up 2 feet by 2 feet, because I don't have a lot of room at my place, with a finished cost of somewhere around $1,500 or so. $1,500 for the whole machine. That will be able to do pretty much anything that you need. Obviously not a lathe, not a heavy-duty mill, but it will do the main things that I need for the 3 products that I want to run. And by having it at home, I get to skip out on the payments that I have to make at Tech Shop. And now Tech Shop dropped a bomb the last time that they sent an email saying that they want $10 an hour after 12 hours of shop time. So after 12 hours of your free hours that you get with the $150 per month subscription to the shop. So instead of paying $10 an hour on a laser, or $3 a minute on their Waterjet, or $10 an hour as well for their router, I will have something that is way cheaper. And I've actually done a little bit of the numbers, and I calculated for the Waterjet to be about $7 an hour to run, instead of $3 a minute, which is $180 a minute if you go to Tech Shop to try to do that. So that is what is 80 divided by 7? 180 divided by 7. That's 25 times, almost 26 times cheaper. And the other option that they have is a plasma, which again we went over is way faster, but that's $30 an hour. And so that is quite a bit cheaper than a plasma, and this has a way better cut quality than a plasma if you have the high pressure and you're going the right feed rate. So overall, I think it's a no-brainer. It's also something my dad's really wants to have a laser, but in this case we would have a water jet, and then if he wants, he could use the laser to etch as well. Pretty quickly and easily swap out that material. Swap out that cutter with, instead of the Waterjet head, you put in the laser head. So yeah, so this is just kind of the start of thinking about it. So I'm going to be doing some designing on this series and some other research offline, off camera, about how I'm going to go about doing it, and what exactly I'm going to need, and all that stuff. Alright, so this has been Steven from the Green Engineers and Legit Tech Tutorials. I hope you guys like this video. If you like this, please subscribe for more videos like it in this series and other series as well. And I'll see you guys in my next video. Thanks for watching. Take it easy. Peace.